Hey guys, in this video we're going to solve a problem involving sigma notation. Given that 10,283 equals 91 times 113, solve the given equation. Well, first of all, we see the sigma notation. It means that the expression on the left-hand side has to be converted into a sum. How to do that? Which formulas for sums do we know? We know how to add up terms of arithmetic and geometric sequences. So, does the expression inside the sigma represent either of these? If you're already familiar with arithmetic sequences, then it's not hard to see that the term 2r plus 3 or 3 plus 2r represents a common term of an arithmetic sequence with a common difference 2. If you're not convinced, try substituting 1, 2, 3 for r and see if you're going to get an arithmetic sequence. Okay, after we have established that, the next step is to write the formula for the sum of k terms of an arithmetic sequence. So I'll write sk equals k over 2 times first term a1 plus the last term ak. You may be used to using n instead of k, but because we already have n in the equation, I'm going to use k to differentiate between n and the number of terms k. So ak here represents the last term. This is the last term of the sequence. Now, although I've written k in the formula, our final task is to find n. N will be the solution to the equation. So we must find a way to convert k into some kind of expressions containing n. The first term of the series is formed by substituting n for r. So I'll write a1 equals 2n plus 3. Okay, so this is for the case when k equals 1. The second term of the series is formed by substituting n plus 1, so when k equals 2, r equals n plus 1, and so on. We're not really interested in the intermediate terms because for our formula we need the first and the last term. So the last term ak is formed when we substitute n squared for r, and that's 2n squared plus 3. Alright, the next thing we need to work out is the number of terms k. So how to work that out? When you see a sigma notation with some, let's say, numerical values, n equals 1 to 10, then how do we calculate the number of terms? We start with 1 and finish with 10, so it's clear that we have 10 terms. What about the case when we have sigma with, let's say, n starting from 2 and ending with 10. How do we calculate the number of terms in this case? Let's write down here we have 10 terms, okay. In the second case, we have 9 terms. But how do we calculate this? So if we try to subtract 2 from 10, 10 minus 2 gives us 8. Okay, 10 minus 2. But we have 9 terms, so we need to add 1. Okay, so let's now use this analogy to calculate the number of the terms in our problem. So the number of terms is, we start with n squared, subtract n, and add 1 to make it complete. Okay, so now we are ready to substitute all of these expressions into the formula for the sum of k terms of an arithmetic sequence. Right, so sk equals k over 2, which is n squared minus n plus 1 over 2, times a1 to n plus 3, plus ak, which is 2n squared plus 3. And this is equal to 10,283. Right, now in the brackets we get 2n plus 2n squared plus 6, and we can see that the common factor of this bracket is 2. That can be cancelled out with these 2 in the denominator. So let's rewrite the expression as n squared minus n plus 1 and times n squared plus n plus 3 equals 10,283. So what we have to do now, we have to do a lot of multiplication. On the left hand side then we have n to the power 4 minus n cubed plus n squared. So I multiplied the first bracket by n squared. Now I'm going to multiply the first bracket by n plus n cubed minus n squared plus n. And finally plus 3n squared minus 3n plus 3 equals 10,283. So we can see that some of the terms must be cancelled out. N cubed and minus n cubed, n squared and minus n squared. Quite nice. So we are left with n to the power 4 plus 3n squared minus 2n minus 10,280 equals 0. Okay, we've got a polynomial equation of the fourth order, and this kind of equations can be solved by using the rational roots test or rational zeros theorem, which basically tells that the root must be a factor of 10,280 in this particular case, because the coefficient in front of n to the power 4 is 1. So we're going to write down the factors of 10,280, and hopefully one of them is going to be the root. The most obvious factorization of 10,280, well, at least to me, is 10 times 1028. Of course, I'm going to check 10, right? If you're working without a calculator, the easiest root to check is 10. So let's try and do that. 10 to the power 4 plus 3 times 10 squared minus 20 minus 10,280 equals 0. So here we have 10,000 plus 300 minus 20 minus 10,280 equals 0. Okay, so that's 10,300 minus 20 is exactly 10,280. So we write 0 equals 0, okay, which proves that n equals 10 is the root of the equation. Okay. And if n equals 10 is the root of the equation, it means that n equals 10 is the solution to the given problem.